Welcome everyone to Learning with Rev. In this video, we are going to continue our tutorial with the sequential Keras model. We're going to continue off from where we were before, where we loaded and pre-processed MNIST data. And in this video, we are going to be building our first sequential model. So the sequential model in Keras is for linear models. If you have anything that is nonlinear, you will either be using more pure TensorFlow or you'll be using the functional API. In the future, I'll also be doing a set of videos on the functional API as well. So to begin, as we can see here, our data has been loaded and we have xtrain, which is our images, xtest, which is the images of the test data, ytrain, labels of our train data, and ytest, labels of the test data. To build our model, we create a model variable here, which is going to be equal to the sequential class here, and we're going to start off with you have a list, and we're going to have an input layer. The shape of our input layer is going to be equal to our input shape. You only have to declare this input layer for the sequential model. For the functional model, you will not need this. And our input shape is equal to input shape here, 28 by 28 by 1. As I've mentioned before, it is that shape because our images are 28 by 28, and there's only one color channel. If they were color images, they'd probably have 3 color channels, so they'd be 28 by 28 by 3. So we have the first layer in our model. Next, we could continue here and add our next element, which I'll do just for now, but you can do model.add, and I'll do that in a little bit later. So our next layer here is going to be a convolutional layer, conv 2D. So this can take a 2D convolution over our 3-dimensional image. Like I said before, 24 by 24 by 1. We are going to give it how many filters, kernel size, what do we want our stride to be, if we want padding or not. It's a great thing about Google Colab. It pulls all this stuff for us. Let's say we want standard one is 32 filters with a kernel size of 3 by 3. So if you don't know what kernel size is or what a convolution looks like, I'll put a link to a previous video where I've outlined what convolutions do. And next, we have to give it an activation. I prefer the activation of ReLU, which is rectified linear unit. You could do linear, you could do many different activations, but ReLU is the go-to activation for most basic neural networks. There are other parameters that we could put in here. Bias, kernel initializer, regularizers, padding, all the other things. We don't need to do that for this basic network. So this is going to be our first, or essentially our second layer. After most convolutions, you are going to add a max pooling layer. Again, I have a video on max pooling, and I'll link that as well. So convolution is kind of going to convolve over the image, and then we use the max pooling layer to extract the features that the convolution has found. So we do a 2D max pooling, and we give it a pool size, similar to the kernel size. Pool size, we'll give it 3 by 3, or we'll give it 2 by 2, so it's smaller than the kernel. And that's all you need for max pooling. We can copy these 2 layers again. So we'll just copy and paste them here. Let's say we want to do a 4 by 4 convolution and then make this 3 by 3 here. We can change these as much as we want. And let's say this is all we want for the convolutional side of the network. Our next step is we are going to have to flatten it to one dimension. So we're going to do this because we're preparing to output our network. This is going to be a classification network, and the classifier is going to give us a value, one hot encoded between 0 and 9. So we want to have a one-dimensional array that is 10 items long. So right now we have 3 dimensions, so we are going to add a flatten layer. No parameters have to be passed in there, which is awesome. And then we are going to add a dense layer. Dense layer, also called a hidden layer, is going to be our classification layer. We're going to give it 10 units. We're going to give it an activation of softmax. And this is going to output values, the probability of each one. So softmax is an activation that gives a result between 0 and 1. And every item in this here, the probability that each one, that the classification will be what the softmax result is. For example, if the first item has like a 0.9, it's 90% chance that the network thinks that this is a 0. If it's the last one that's a 0.9, it's 90% chance that's a 9. And then we close off our model here, and we can do model.summary. So if we've done everything right, we should see a summary of our model. We have our input model. Input is not shown, but we then have our convolutional layer. Output shape is 26 by 26 by 32. This 30, I'm not sure what that 32 is. I think that's going to be the default for batch sizing. Then we do a pooling layer. Then we have another convolutional layer. Then we do another pooling layer. Then we're going to flatten it and gather our output values. Another thing we can do is you can use this other function here called plot model. It's a great way to visualize your model if you don't really know what it is. So if we just plot model right here, see our input layer goes into the convolutional layer, goes into the max pooling, to the next convolution, to the next pooling, flatten, and then dense. So this is all we're going to do in this video, just building our model out. In the next video, we'll go through all the steps of compiling that model, training that model, and maybe doing a little testing of the model as well. So if you have any questions, please leave them in the comments section. If you like this video, give it a thumbs up and share it. Thank you all for watching, and I hope you learned something.